Is a question where we are trying, based on this section, to create a rational, so this is our first time, a rational equation. I don't think we've ever done a rational equation before. So remember, rational equation means that there needs to be an x in the denominator, right? X in the denominator, not just a number. If it's just a number, it's not a rational. So rational equation means there should be an x in the denominator. So we can think of that. So x in denominator, right? So that's what I'm thinking in my brain. I need to have a variable in the denominator. If not, it's not a rational equation. So this is a different kind of question we're doing. So Rima bought a case of t-shirts for $450. She kept 2 for herself and then sold the rest for $560, making $10 on each t-shirt. How many were in the case? So what we don't know is we don't know how many t-shirts there are. So I'm going to do my let statement first. How many were in the case? So let x represent the number of t-shirts in the case, right? So in the case that we bought. Okay, so how many were in the case? Okay, so now we have a few things to look at. So we are going to look at Rima bought a case of t-shirts for $450, and this is the X t-shirts in this case. Does that make sense? These two match. It's these ones, $450, so she bought the case at $450, and this is the X that matches the $450. All right. Then she kept 2. She kept 2, sold the rest for $560. So then she kept the 2 and sold the rest at $560. Those two are a set. She kept 2 and sold the rest for $560. She made a profit of $10 on each t-shirt. These are 3 pieces of information. So $450 matches the X in the initial case. The way we're going to try to get the variable in the denominator, the X in the denominator, is we are going to use a rate or a ratio. Ratio or rate. It depends on kind of which way you look at it, but they're the same thing. A ratio and a rate, or a rate. Okay? So what I'm going to do is I'm going to do the rate of how much was it per t-shirt, right? So the rate, or some people consider it a ratio, but the rate of how much she was selling each t-shirt for. So she has $450 at X t-shirts. So that is one rate, $450 per X t-shirts, yes? So say, for instance, oh, and I'll write that down first. Let me write this down. So one of them is $450 for X t-shirts. That's one rate. Okay, then my other rate is that she had $560 for X minus 2 t-shirts. That's another rate. This first one here is what we bought it for. So I bought it, or she bought it, and this is sold. Right, so she bought it at the rate was $450 per X t-shirts. Right, so maybe that was 10 t-shirts, right? So $450 per. This sold, she was selling it at $560 for whichever number of t-shirts. So these are both rates. The last one, she has a profit of, so this is going to be profit, is also a rate, and it's $10 per one t-shirt, for every one t-shirt. So see how they're all written the same? So $450 for that number of t-shirts, $560 for that number of t-shirts, and now it's $10 for one t-shirt profit. So these are rates. So you're trying to get the X in the denominator by turning it into a rate. Now, the example I can give you, if I sold the t-shirts at $10 each, okay, so I've got $10 each. And, sorry, if I bought the t-shirts, so say I bought the t-shirts at $10 each, so that's me. I'm like, yay, I bought them at $10. I'm bought. I'm selling it at $15 each. And I have a profit of what? $5 each, right? So those are each by 1. These are not by 1 because it's still 10. So if I said I had 10 in the box, that would be 100 for the 10, right, etc. So that's why. So it's a rate. Does that make sense how I got the rate? Right, so dollar per number of t-shirts, dollar per number of t-shirts, dollar per one t-shirt at the end for the rate. So those are all rates. How do I make these 3 into an equation? If I go I bought it at $10 per t-shirt. I sold it at 15. That should equal $5 per t-shirt. I need the difference between these two. Am I going to do bought minus sold or sold minus bought? Which way? This way or that way? Yeah. Yeah, and when you put the numbers in, it makes sense, right? Sometimes I do this and you're like, I don't know. Who knows? So think of the price. You bought it for less, you're selling it for more, so therefore that's your profit. So we want to do sold minus bought equals the $10 each, right? So when I put numbers here, you go, yeah, well, because you sold it for more minus what you bought it for, and that gives you your profit. So we're going to do it this way. So we're going to go 560 over x minus 2 minus the 450 over the x. So I sold it at this amount more minus what I bought it for, and that gives me the $10. You can put the over 1, you don't have to, but it's $10 per t-shirt. They're all ratios, they're all rates. Right, so this is the rate minus this rate, which gives me 10. Okay, so that's the type of word problem you'll get, where you're trying to churn it into a rate. Okay, so try to churn it into a rate. And again, if this feels weird, it's because we've never done a rational equation before. We never tried to get a variable in the denominator on purpose. Right, so this rate question is a good way of getting you into the denominator. And again, we've never done that before. All right, this is the context. This is the type where I have 3 terms. I can't just cross multiply, right? Because there's not two terms for cross multiplication. Once it's 3. So what I picture in my head is that I'm multiplying all of them by the lowest common denominator, which is x minus 2. That one's just a 1. So you don't have to write this, but you're doing that for all 3 terms, not just 2. So that's why multiplying by lowest common works for any number of terms, not just 2. So this one, so again, you don't have to show that, but this one here, if I multiply by this, I would get 560x. Does that make sense? Because the x minus 1 cancels out. Okay. This one, if I multiply by x minus 2, the x's cancel out, so I get this. 450 x minus 2. Okay? And the last one, you get x minus 2. I didn't need the bracket, sorry. Okay, so this one gets both. This is where people make a mistake, because the third term, they ignore it. They do 2 of the terms, they go, uh-oh, I can't do cross multiplication. So that's why cross multiplication is good for simple cases. When it's not, you're imagining what was actually happening, which is I'm multiplying all of them by the same amount. This cancels out with this one, so I'm left with x. This cancels the x, so I'm left with x minus 2. This one gets both of them. Okay, both of them. So then the bottom here is... No question? Okay. All right, and then now we just go ahead and we're going to do, so this is 10x times that. So you can go faster or slower, up to you. 560x minus 450x plus 900 equals, and this is actually just 10x times x minus 2, and then bring it in. Or you could have done that all in one go. 560 minus 450 is 110x. Right, and again, I know you can go a little faster, some people, so that, bring it over. I didn't do restrictions. Forgot. Always do restrictions. Sometimes you start to solve. Stop yourself as soon as you realize and go restrictions. So I have to do restrictions. So my restrictions in this case would be, I'll just do comma over here, x cannot equal 2 and 0. So that's the mathematical restriction. Does that make sense? So mathematical restrictions are good. However, now you have to look at the context. So the mathematical restriction is not 2, not 0. Now look at the context. What's the context restriction? Read through that. Yeah.
Has to be greater than or equal to 0.
0.
Greater than 0, sorry.
But will 0 greater than 0 work? So read it one more time. There's something else that's going to, yeah. What do you
Greater
think?
or equal to 10?
10? Does it say specifically that it has to be 10? Did I? T-shirts sold the rest for $560. $10 in each T-shirt. What's the minimum number? What do you think?
It has to be a whole number?
Has to be, oh, definitely, yes. So x has to be a whole number, right? Also, one more restriction, back corner, yeah.
Greater
Can it equal 2?
Sorry, greater than 2.
Yes. Greater than 2?
She keeps 2.
Yes, that's it. So that's why. So we've never done one where it's like, wait, what do you mean? Mathematically, we've done mathematical restrictions and we've done context. But the only context ones we did were the selling, the X, right, profit one, and also the shape. This one has a totally different. So it can't be 2 because she kept 2 T-shirts. How do you keep 2 You can't have 1. So it has to be a whole number. So this one, yes, definitely. I won't make you state the whole number part. So this one that you should know, I won't make you state it. Okay, technically you should. I'm not going to make you state it. That you should know in your brain. So I'm assuming if you get a decimal, you should be like, huh. So she gets that, but I'll cut a sleeve off? No, you can't, right? So you should know this. I'm not going to make you state that, but that you should know. Like when you get your answer, it definitely has to be a whole number. Okay, because we're talking about items, so 0, 1, 2, 3, when we're talking about items of T-shirts. But also here, X has to be, so again, this is the place where I would usually state it again. I would say X has to be greater than or equal to 3. And then I do a conclusion, X is greater than or equal to 3. Some people ask, do I have to state it twice if I'm going to conclude it? That's okay, I'll leave it there. I need to see this, the mathematical restriction for sure. And then if you conclude it right away and go, but this is also what happens, I won't make you write it twice. Okay? But that, I need this one, because now you know I cannot actually get a 1, right? Because some people go, 1 works. Nope, doesn't. You kept 2 T-shirts. Okay, so it's not just math. So that makes it more interesting. You got a mathematical restriction, but you also have a context restriction, right? Which doesn't come up anywhere except for in the words. All right, so there's my conclusion. So no, you don't have to state it twice. If you look and go, but wait, then you can just do your final statement. So I've got that, but I do want to see that. Yes?
Liz, how can it be free?
It'd be a very, very expensive T-shirt. If I kept 2 and I sold the last one at $4.50, that would be quite the, yes, that would be quite the profit, wouldn't it? But yes. But yeah, have you seen some of the clothes out there? Yeah, there are things out there that cost a ridiculous amount. So yeah, so you just think ridiculous. It's a ridiculous price, but based on the context, it could happen. Yeah, just be a very expensive T-shirt. Yeah, okay. There you go. So you go 3 because it'd be 3 minus 1, so 560 is your profit. So you sold the last one at 560 and you made the profit. Yeah. Okay, so yes, it would be a large number, but yes, there are things out there worth that cost a lot. Okay, let's finish this off. So as soon as you realize, I stop myself and go, crap, I got to do that, right? So do the restriction. So all of these guys, you got to keep asking yourself, denominators mean restrictions. Okay, and it'll be the same thing for the next section as well. So we're going to go 10x squared, bring this over, negative 130x minus 900. This here, because it equals 0, right, you know you can divide the whole thing by 10. Right, you don't have to show that, but I can divide the whole thing by 10, and you get x equal x squared minus 13x minus 90. You don't have to. You can just solve it with the bigger numbers, but because it equals 0, okay, you can do that. And also, because we know that there has to be at least one whole number in this, like there could be a whole number in a decimal, and you'd be like, that decimal doesn't work, but there should be one whole number. It actually did factor. So this was 18 and 5. Right, so maybe try factoring before you kind of go to the quadratic, and then you get x equals 18 and negative 5. When you, first of all, I want to point out 2 things. Can you please not drop your zeros? A few people, right, and this shouldn't be happening in grade 12, you should not be dropping your zeros. If it's a 0, you must state it. You can't drop it there. If you do, you're losing little half marks, right, for communication. So zeros stay. If it's a formula, like I said, P equals, area equals, you can drop it there, but not zeros. You don't drop a 0. A 0 stays there, so don't drop that. It's little half marks that people are missing. Then we get this. When you cross this off, in younger grades, some of your teachers said just cross it off. That's fine. Okay, I want you to state something underneath. Most teachers ask you to state something underneath. Not all, but I want you to state, because again, grade 12, we're going to say cannot be negative. Or you can say must be a whole number. Right? Or must be positive, something. So state something so that I know why you cross it off. Because again, it's not always cross off every negative. We know that now, right? Sometimes a negative number is an impossible answer. right? When we're talking about context, sometimes a negative does work, right? So don't cross off every negative, look at the context and say, yep,
So it doesn't really matter much, but it should be x, or it should be negative 50 instead of negative
8.
1. Or did she factor in?
I took out divide by 10.
Oh, my bad. I didn't see
Yeah,
that.
because then I don't have to do the 10 in front of it, so it'd be 10x and 50, yeah. Yeah, so I took out the 10, so then it becomes x squared, 13, and 9, and then I have only coefficients of 1. Yeah. You can do it with the 10, though. It would just be 10 and the 50, or it'd be 10 and the
You
180.
get the same answer.
Yeah, you get the same answer, yeah. Yeah. Yeah, so you can leave the 10 in or take it out. You'll get the same answer. Okay, so when you cross it off, please tell me why, and then you're going to say your conclusion. So I already did my restriction. I looked, and it's fine. If for some weird reason you got 2, you'd be like, ah, really? That was mean. And then you'd say, no, it can't be because of that. Okay, but still want to state it there, and then conclusion. So therefore, how many were in the case? There were 18 T-shirts in the case. Okay, and then concluding sentence, making sure it makes sense, all that jazz. Okay, so no more losing zeros and little things like that. Good. Done?